Okay, let's now introduce a new concept about functions called the restriction of a function. We already have seen something on these lines previously, but now let's make it more concrete. For that, let's introduce the following example. So recall, where did we start with this course? With the two sets. Two sets with students, the friends set, with Abby, Eve, John, and Hugo, and the set with their heights with 160, 170, 180, and 190. This is what we call X, and this is what we call Y, the height sets. Now, recall that making the Cartesian product between these two sets and now taking some subset of it, a special subset of it, we arrived at a function f which labels Abby with 170, Eve with 170, John with 180, and Hugo with 160. This is one example, one possible subset of the Cartesian product between these two things. But now let's take another. Let's call it G, another subset. So with Eve 170 and John 180. It's also a subset. So, and because again the first entries are only appear one time, so this is again a function. So this is two examples of a function. Let's make a diagram of both. A diagram for both. So here is our set with Abby, Eve, John, and Hugo. A160, 170, 180, and 190. And the first function here, the f function, here, let's put in blue, assigns the thing like this. Eve here, John, and Hugo. Okay? 190 does not belong, it belongs to the y set, okay? But to the codomain, but does not belong to the range. The range of the function is just 160 through 180, okay? Now, this is our first function. Let's now draw the second one. So the g function here, it's, you see, Eve 170 and John 180. So it's this arrow and this arrow. Okay? So, two sets, Cartesian product, two special subsets, two different functions. Okay, everything now is fine. But now, just compare the two. You see? Just compare the elements in this set and this set, and you notice something interesting. What is interesting is that this thing is a subset of f, because every element here is in here. Okay? On the picture you see this blue arrow is the same as the green one, and this blue one is the same as the green one. So this function is a subset of this function. Okay? Or in other words, let's give it a special name. Instead of G, let's call this the restriction of f onto E and J. Let me write it. So f restricted to the set A. What is the set A? Well, the set A is this one. So A is the set with Eve and John. It's the domain. It's the domain of G. Is that right? So this is the domain of G, and what we say is that, well, the G function that we just constructed is the f function, but just take the elements where the first entry is in A. Okay? So this is the restriction. This is what we call the restriction of f into the set A. Okay? The domain of this function G. Notice this is very important. I think it's I'll make it I want to emphasize it. F and G are just by themselves functions. But when we write this thing, we want to emphasize the fact that when you compare both, this one is a subset of this. Or in other words, this thing is a restriction of this thing, is a restriction because you are thinking about f, but only about those two terms of f. Those that where the first entry belongs to A. Okay? And so to emphasize that idea, I just write instead of a generic variable g, I want to emphasize it. Well, it's f, but only the first entries that are in A. Okay? And so we have the restriction of a function. Now, this is quite easy to understand when we see the function from the point of view of the relation, because now the arrows are explicit, everything is clear. Let's now see the restriction of a function, but from the point of view of the procedure. So let's introduce here some generic function f, which has some domain, it doesn't matter which domain it has, and maps those elements into y, the codomain. So x's are mapped into f of x. Somehow they are mapped, the f is some procedure, and x is assigned to f of x. I could now, so by these, in other words, this thing establishes a connection between the x elements and the y elements. But now what I want is just some of these connections. So let me write here g, and g maps elements of A into y, and x are mapped into g of x. But g of x is what? What is this number? I want this number to be the same number as f at that x. Okay? And so here we have the same. This function is constructed from this function. How? Well, it's just instead of thinking about f acting on all possible elements of x, the domain, let's just consider a subset of x, namely A. So A is a subset of x. And I'll just think f acting on those elements, well, gives us the function g. To emphasize this idea, I'm going to instead call this function, instead of g, let me give it a special symbol to remind us of the fact that this thing, this g, is like f, but with domain A. It's like f, but with domain A. Okay? So, and now you can see that this thing is just the connections between A and y. They are the same connections that the f function do between the subset of x, A, and y. Okay? So, f of A here is a restriction. So it is a restriction of f into the subset A of the original domain x. Okay? Now these are the basic ideas about restriction of functions. Notice the only thing that is new is the fact that we give a special symbol to these functions. Okay? Because you see, previously we already saw that, well, if you have a procedure, well, you can have many domains. You can have the largest possible domain for that procedure or a smaller one. But now we have something further, a new idea, is that when you have the same procedure and two different domains, well, if one domain is a subset of the other, you see, you have two functions. One is with the domain, one of the domains is a subset of the other, then you are essentially comparing the two functions. When you have two functions, and you say that one domain is a subset of the other, you are comparing the functions. And to emphasize that idea, well, we introduce a special symbol to say that one is the other, but restricted to that subset. Okay, so we speak about the restriction of a function. So this is the only new idea. When you compare different functions, you have a special symbol for it. Okay, to remind us of that idea. Okay, let's now see some examples.